Welcome everyone to today's ONUG webinar titled Enabling End-to-End Automation for Multi-Domain Enterprise Networks. I'll be your host. I'm Steve Collins, ONUG Working Group CTO. And today's speaker is Chris Wade. He's co-founder and CTO at Itential. Chris will be talking us through some of the challenges confronting operators of today's multi-domain enterprise networks that are starting to include, these new constructs such as SD-WANs and multi-cloud networking, essentially highly complex environments where automation tools are kind of sorely needed. Chris will also be talking through some specific use cases and recommended approaches to end-to-end automation. Before I turn it over to Chris, I want to make sure everyone knows there'll be time for questions with Chris at the end of the webinar, probably in the last 10 to 15 minutes. So if you have any questions, feel free to ask them at any time. You can do that by just accessing the Q&A tab in your Zoom dashboard and enter your question. We'll keep track of those. So without further ado, let me turn it over to Chris.
Thanks, Stephen. So I'll just go through a quick agenda and then we'll jump right into it. So we'll do a quick Itential overview, and then we're going to spend some time talking more about the market. So it's really about what is the evolution of automation, what is the concept of domains in this discussion of multi-domain, and then we'll hand it back to Stephen for a few minutes to talk about how this applies to some of the ONUG working group activities, which I'm sure a lot of the people on the line are participating in. And then we'll talk about different domains, and we'll talk about automating that journey with some of the Itential solutions. And then ultimately where this is going to end up is talking about some infrastructure as code concepts. So at the end, we'll wrap it up by talking about what we think the future state is. So from an Itential standpoint, for those who have not heard of us before, we're focused exclusively on network automation. And how we got started was really around the concept of the management plane within networking beginning to get some investment. So as Stephen talked about at the beginning, the adoption of things like SDN constructs, the adoption of controller concepts into networking domains, the adoption of some orchestration has really changed how we manage networks. So traditionally we've had SNMP, we've had CLI, and we built very verticalized solutions on top of those very human-centric interfaces. So what Itential focuses on is how do we provide automation leveraging these modern networking concepts. And obviously we have some very large customers, some of the largest networks in the world leverage Itential to help with automation, spanning service providers, financial services, and the US military. So we'll get into some of the details. So as you get to learn more about Itential, we do think it's important to talk about kind of guiding principles, how we see and view the market. So some of these things are, the first one is networks are a critical path. So everybody that's focused on digital transformation, there's been a lot of focus on compute, a lot of focus on storage, a lot of focus on cloud. And now with some of the advent and some of these modern networking concepts, we're really seeing the network be the critical piece that's inhibiting a lot of the growth towards folks' digital transformation strategy. So, we're very excited about the volume of network discussions driving that discussion. The second is around the management of networks. Historically, when people bought networks, we really focused on speeds and feeds. We still see this in the data center, moving from 100 gig to 400 gig links. But I think we're seeing a lot of people talk about how it's more important to get bandwidth out of the network that's already purchased than talking about just the new box with the new speed and the new feed. So we believe how you manage your network is becoming at least as important as the bandwidth of the network. And we're seeing, especially with a lot of the modern networking concepts, the amount of flexibility, the amount of orchestration, the amount of machine programmable interfaces really provide us the ability to get the most out of what your network is today, especially as you adopt these modern network concepts. The next is around complexity. I think when SD-WAN first rolled onto the scene, there was a thought that it was going to be, simpler than its predecessors. SD-WAN provides a great business benefit. It provides a lot of operational flexibility, but with that flexibility comes a level of complexity, especially as we get into SD-WAN 2.0. Combining the complexity of SD-WAN with some of those cloud concepts really drives the level of complexity up, and really requires a level of automation to level set and make sure that that complexity doesn't negatively impact your ability to operate the network. The fifth is the future state. So we'll talk about this at the end, but really focusing on infrastructure as code as the future of network automation. And we'll talk about how we can think about code snippets and how we can think about leveraging GitOps concepts and the ecosystem built around application development and apply that to network automation concepts. And then on the right-hand side, we really believe it takes an all of the above strategy. When we talk about multiple domains, we'll talk about the cloud domain is different than the IP domain, which is different than the wireless domain. So it's really about using the right tool for the right job within each of those domains. And we see a lot of discussions around standards bodies and a lot of effort in best practices and POCs to determine the right way to do stuff. And we do think that in this concept, there is a right way to do it within each domain, but we need to focus on kind of an all of the above strategy and a right tool for the right job concept. The fifth is quality data. So when we talk about the quality of data we have in our CMDBs or in our resources, or how accurate the network is configured. Automation as we move to this machine-centric world requires high quality data to make these automation decisions. So historically, the data has not been very good in our CMDBs or our inventory systems, and that's really relegated to, that was the level of quality required for human-centric processes. So there's a lot of effort both in standardization to support automation, but we think it's equally important to talk about the quality of the data so we can have the opportunity to make a lot of those decisions in the automation platform. And then the last, and this was kind of talked about with different controllers and orchestrators, and we'll get into this, is this concept of source of truth. So we've gone from systems being the source of truth to now being the network as the source of truth. And we really believe we're going to live in a world of a highly distributed source of truth. And what we mean by that is that if you adopt an SD-WAN platform or you adopt a data center overlay controller, those controllers are really software representations of what's deployed in the network. So it's best to have access to those systems in real time to understand the current source of truth, especially with the velocity of the network increasing every day. So focusing from an automation concept of expecting to live in a architecture with a distributed source of truth and accessing those systems through their APIs in real time. So those are some of just the baselines to level set. And then I kind of alluded to this concept with automation and thinking about where we've come and where we're going to with the move of moving from a human-centric view of the world to more of a machine-centric view of the world. So if you take kind of those guiding principles and you apply it to kind of an evolution of automation, today I continue to hear from analysts that we still live in a world that is predominantly CLI driven. So when we think about a human-centric way of automating the network, obviously the CLI is the core set of that, even with scripts driving some of those CLI and repeatable CLI commands. And the next is that quality of network data being quite low. And it's low because we have human-centric processes surrounding it. And it that low quality of data is augmented by the network engineer's knowledge of what needs to happen. And we'll talk about that. And the third is really the IT system integration tech. So historically integrating with the rest of your IT systems, sometimes the network was separated by those IT systems by a human, swivel chairing between ITSM systems or self-service types of portals. And we'll talk about how that's changing. So if we start moving towards the right-hand side of how a machine-centric world would compare to that, the first important concept is that the network needs to have some programmable concepts so that we can program on top of it. So the network being programmable, going back to that concept of a distributed set of controllers and orchestrators, we need to expect to live in a very federated world, especially when we start to talk about SD-WAN 2.0 with multi-cloud concepts. You're going to have a variety of systems, probably more than you at the onset believe you will. And we need to be able to talk to those systems in real time to understand the state of current network services so we can continue to make those programmable machine-centric automation decisions. So whether it's RPA, which has got a lot of push within the IT domain, we're really moving more towards a model-driven view of the world. So those models can be represented within operational processes. They can be represented within network services, but we're seeing more model-driven concepts combined with that programmability to provide a more machine-centric world. And comparing to that IT system integration tax where people felt like it was a large burden to connect the network to your IT systems, the dominant, the open API concepts and the REST standards that have been making their way through modern application development has really removed the barrier to build integrations. So having that open API ecosystem really allows us to connect the network and this variety of controllers and orchestrators directly into our IT systems. And ultimately tying both those SD-WAN concepts like we talked about into data center and cloud connected services. So it's really a mixture of hybrid with the on-prem and cloud concepts with a variety of SaaS-based types of implementations that people are starting to use for their network. So really evolving automation from a human-centric view of the world to a machine-centric view. So we wanted to introduce this concept of multi-domain. I've seen some different, I've seen the use of the word, but when we think about multi-domain, we really historically have built management platforms focused on vendor OSs. So, I might have a certain vendor in my data center, or I might have a certain vendor. I might have two different vendors for my branches, and my network tools and my network management platforms and EMS systems that were provided by those vendors were very kind of vendor specific management. And then we built NMS platforms on top of it. So the benefit of moving to a more technology-centric view of the world and the benefit of having open standard interfaces is now we can think about network management concepts in a domain perspective with a little less concern for vendor-specific nomenclature. So when we think about solving, and Stephen said at the onset SD-WAN, and that's a big use case within the Anode community, so I think we'll kind of use that throughout the presentation in the upper right. So if we think about the challenges for a branch or SD-WAN deployment, there's certain techniques, there's certain protocols, there's certain modeling techniques, there's certain challenges specific to SD-WAN that are different than maybe how I manage my load balancers or my DNS infrastructure and my network applications, or different about how I manage my multi-cloud infrastructure in the cloud, or how I might manage my Wi-Fi or my wireless infrastructure. So when we think about, and we don't have time today to go through all 8 of these, we'll dig into 2 of them later, but we really want to think about how do we take an overall network automation challenge and how do we break it down into specific domains and have a strategy within that domain, and ultimately tie it together as an end-to-end concept, federating those APIs from those domains and providing an end-to-end automation concept. So if we kind of move on with that towards an automation journey, and this is a question we get from a lot of customers, is we agree with the guiding principles, we agree with where the market's going, but I'm somewhere today, I want to be somewhere else in the future. And how do I move from where I am to where I want to be? So, depending upon your domain, depending upon your existing infrastructure, depending upon your target architecture, there's varieties to this, but I think this kind of maps to the reality with most customers today. So if we look in the bottom left where we start, people have historically had a very CLI-centric manual view of how they operate their network. And there's always been a drive to script some benefits on top. And obviously that, any move towards automation is viewed as beneficial. There are certain script concepts, and that's why we kind of have it moving over to the left with modest improvements. Most people say they get me to a certain point, but then at some point they're complex to manage, and people are moving to leverage a lot of the DevOps principles from the IT and cloud side of the equation, and mapping that to the network to take those scripts and create more modular frameworks, accomplishing similar automation on top of CLIs. In a previous webinar, we talked about how Itential helps bridge, your script concepts with your DevOps concepts, which we could talk about another time. So if we take those DevOps concepts and we think about our existing network, which is a very CLI-driven platform, we do think you can get great benefit out of leveraging DevOps platforms and some modeling techniques on top of your CLI, which is still going to be the predominant way changes are pushed into the network to really make great progress towards your automation. Now, in addition to that, you're going to adopt some level of controller infrastructure, orchestration infrastructure, SD-WAN, and intent-based systems. And those new modern network concepts come with more programmability out of the box. So when we think about the level of automation that we can apply to those modern networks, coupled with how we make traditional networks look more programmable by putting DevOps concepts and some orchestration concepts on top, the goal is really to drive towards that joint platform. And that's where Itential focuses on, is how do we provide an end-to-end automation platform that leverages both your new modern networking techniques that understands, Tosca and Yang, understands federation of APIs in real time, and joins that with your automation techniques that you're applying to your existing network, so that you can have a single operational environment to drive the adoption and programmability with all the benefits of self-service and end-to-end automation. So how have these domains evolved? So when we first started Itential, there was a concept around having a single data center controller, a single WAN controller, a master orchestrator, and magic would happen. And the idea was, we're still working through this in the open source community, is how do we drive generic frameworks to adopt these concepts? So early on, whether it was ODL or ONOS, there was a lot of open source frameworks that was really driving the concept of separating control from data plane, and really understanding how can we have a simplified orchestration and automation environment to drive this automation vision. And what's happened is that we've actually, instead of having generic concepts of orchestration and controllers, we've really had the embedding of these concepts in a lot of vendor and open source ecosystems. So instead of having a single data center controller, or especially a single WAN controller, we're seeing kind of an explosion of controllers and orchestrators. We're seeing the adoption of most all DevOps concepts for anything that falls in the gaps of those controller or orchestration concepts. And then ultimately you have a different kind of ecosystem of these for each of these domains. So we think this has really driven the need for tying these platforms together, so we stay away from why we started all of this as a ecosystem and as a market, is that the verticalization of network management is really what minimized our ability to execute on making the network a self-serve, on-demand ecosystem that drives our digital transformation needs, which we started out with. So it's really about how do we take these great innovations in each domain and the adoption of new networking concepts in the cloud and in the WAN and in the branch and in the data center, and how do we tie them together in the most effective and automated and API first way. So if you think about taking what I've said so far and trying to turn it into kind of an incremental strategy, we kind of break down those strategies into a few groups. So you've heard me talk about this a little bit now, but there's really kind of the API first strategy. Anything that's going to be machine first and programmable, we really need to think about what we're doing with the API. The second is, how do we look at the models? With REST interfaces dominating a lot of the kind of controller ecosystem right now, it's really around some JSON and JSON schema for modeling. The third, resource state. So that's things like IP addresses, VLANs, port assignments, things that are not tightly coupled with our controller and orchestration ecosystem, but things that we need access to. And that goes back to kind of that high quality of network data, so we can make those automation decisions on the fly without human intervention. It's really about getting the topology and configuration and ultimately performance information. So if we break it into those five kind of groups, and we could go into detail with more, then we really need to look at what is the right technique for each of these domains. Is this a domain that is dominated still by CLI? Is this a domain that has evolved to more of REST-based interfaces? Or is this more of an IP type of environment that is migrating towards a netconf centric view of the world? And then look at those modeling techniques. Is it YAML? Is it Yang? Is it Tosca? Is it JSON? We need to understand how to federate those models from those systems so we can have the most robust interface to be able to adjust our automation decisions on the fly. So if we look at kind of those domains and those strategies on a per domain basis, then we look at it from a multi-domain perspective. So if I have some domains that are netconf and some that are REST and some that are CLI, the question is, how do I consume those APIs across each of those domains? And the second one is, how do I federate those models from those different controllers and orchestrators so that I don't have to hard code data structures on top and restrict my ability to make changes on the fly without breaking automation? The third is, how do I have real-time integration to those resources and automation logic? And back to the high quality data, how do I make sure that I update them after I've made those decisions so that those systems can reflect the reality of what exists in the network today? And then we think about topology and configuration. This is what we're going to talk about a little later with some infrastructure as code concepts, but it's really about what is the source of truth within that domain, and what is going to be our source of truth within the multi-domain concept. So is our CMDB the source of truth? Is the network the source of truth? Are we putting the source of truth in a Git repo, which is where we think we're headed with most of the domains? And ultimately, with telemetry and NPM, APM systems being the predominant way to manage the performance of the network, we need to have a very event-driven integration, and we need to expect automations to be very, very much event-driven in the future. So a bit on just Itential and how we kind of capture some of this, and I'm going to turn it back over to Steven to talk a little bit about Onug. So we talked about those different multi-domain concepts, but something that, to combine that with that first one, multi-domain, we spent a lot of time kind of talking on that. The second thing is really the connect to everything. So, we believe Itential has commoditized the interface to those networks. So any automation system you talk to is going to have a way to connect to other things. What's dominant within our ecosystem is really that concept of Swagger documents or open API specifications. So the ability to auto-generate adapters to all those systems, and we've open sourced all of those adapters online. We really want to focus on network automation and really remove the barrier to integrating it with your choice of ticketing systems, your choice of resource management systems, your choice of self-serve. So connecting to everything we think is very important. Combining some of the developer concepts with low-code environments. We're going to talk about how we can use kind of low-code drag and drop interfaces with the goal of having the largest volume of participants from your organization. There's been some concern about moving towards resources that are both developers, network engineers, and DevOps professionals, understanding infrastructure as code. And the feedback from a lot of folks is that there's not the largest volume of resources in the organization that can do all that. So when when necessary, provide developer interfaces, and when necessary, provide DevOps interfaces to the professionals that are dealing with that, but also augment that with some low-code interfaces so we can have the business owners actually understand and be able to interface with the system so they can drive their automation decisions within that platform. And ultimately building pre-built automations. So there's a lot of uniqueness with how you operate your network, but there's some basic principles around software upgrades and load balancer changes and firewall changes that we can start with some common set of automation and not require everything to be as bespoke as it has been historically. So with that, I'll pause for a second and let Stephen talk about some of the Onug working groups and how some of this pertains to the work that is happening in Onug.
Yeah, thank you, Chris. Yeah, I think this is all, very relevant to where the Onug community is today, and specifically what's going on inside of the different Onug working groups, which are all currently looking at different challenges that enterprises are facing, trying to adopt application deployment in these hybrid multi-cloud environments. So they're obviously complex. They are inherently multi-domain. If you look at that diagram there, you're spanning multiple network domains. You actually have domains that even with a specific area kind of operate at separate layers with separate controllers at different layers. You've got different public cloud services. You've got SaaS applications. You've got workloads running in different execution environments. Seeing the adoption of these large-scale, kind of highly dynamic service meshes, and also a lot of dependencies on third-party services, and then of course leveraging a wide range of connectivity options. SD-WAN's kind of the newest thing, but you still got VPNs, internet, wireless, and carrier-based connectivity. So it's really a different world than we've been operating in for the past couple of decades, right? It's a world also where the enterprise doesn't have direct control over much of this infrastructure. So a whole bunch of challenges here, and the working groups are looking at security challenges, observability challenges, SD-WAN connectivity challenges, and if you go to the next slide, Chris, we're also launching a new working group, which is focused on orchestration and automation. So this working group is specifically looking at the challenges of applying orchestration and automation techniques, to streamline, workflows in these hybrid multi-cloud environments, basically trying to get the machines to do the work. And it's focused on a lot of things that Chris is talking about here today, right? We're also looking at, orchestration and automation spanning not only the network layer, but the infrastructure layer and up to the application layer. It turns out at the application layer, they've already gotten a pretty good running start on employment of automation techniques, but that has to be kind of driven down right through to the network layer. And I think as Chris pointed out, the overarching goal here is, infrastructure as code. It's kind of a common buzz phrase, but we really need kind of a new approach, I think, to fully realize that. Just some of the kind of top issues and concerns that have been kind of floated within this working group are, as Chris noted already, there is a proliferation of automation tools, right? There's no shortage of methods for doing automation, but there's still a lot of different point solutions out there. And what we're really lacking, and I think the folks in the working group who've been thinking about this believe, we're still kind of missing that kind of commonly accepted across the industry, framework or approach for this, and also a need for kind of well-defined abstraction layers and APIs, so you can, basically realize that goal of infrastructure as code. So everything we're talking about today in this webinar is, again, very relevant to the challenges the owner community is facing, and also the specific working group that we're currently launching, and which will kind of have its unveiling at our fall event in New York in about a month. Turn it back over to you now, Chris.
Awesome. Thanks, Stephen. So So I think we went through kind of how we take each of those domains and tie it together. So I think we'll, let me skip this slide. So, so as reference, maybe I'll skip back because that was the purpose of that. So we talked about these 8 domains, and we really want to talk about how do we tie these domains, because modern services don't stay within a single domain. So especially with the last Onug show we were at, where it was SD-WAN 2.0 was a large discussion topic within our working group. It really spans multiple domains. So future state network services are not going to be nice and just stay in the data center or just be cloud centric. They're going to be a combination of these domains for the challenge that you're trying to solve. So with that, we just from a time constraint perspective, we just wanted to kind of show 2 examples of how we think about this that might make it more clear. So when we think about multi-cloud, we have the cloud ecosystem, but on top of that, when people think about using immutable infrastructure, or they think about monitoring multi-cloud platforms, as Stephen pointed out, there's a variety of tools you could do that. So when we think about a multi-domain automation platform like Itential, we think about how can we help customers automate the networks that traverse these things, because they're already going to have some tooling in place. They're already going to think about trying to build some abstractions on top of cloud-specific APIs. But the reality is that those multi-cloud platforms and those DevOps solutions are consuming a subset of that entire cloud API set. So, if we think about how many APIs does AWS provide, the numbers are very large. But if we look at what a team has built within their DevOps platform to spin up infrastructure, whether virtual or container, or maybe they're managing VPCs, that's a pretty small subset of the overall AWS ecosystem. So when we think about building some end-to-end automation concepts, I might need to combine some direct AWS API consumption with some execution through a DevOps platform, maybe an Ansible or a Terraform, which might be doing very specific VPC management, or it might be doing very specific overlay networking, or it might be managing some virtual network infrastructure that's being deployed. And then there might be some multi-cloud concepts where the customer's built some abstractions, and that's the preferred interface. So from an Itential standpoint, we believe it's important to use the highest level abstracted interface that is made available to us, and that's independent of domain, because if somebody spent the time to put a controller in place, or if somebody's spent the time to even put scripts in place or put a DevOps process in place, we want to leverage that intellectual property that's already been put in place, and we want to drive that. When nothing exists and the most obvious answer is to go directly to those systems, then that's what we do. So that's why we try to build that large ecosystem of adapters. And specific challenges within the cloud domain is that just the number one is the pure volume. So there's robust API that exist, and there's of all the domains, there's a lot of tools to choose from. There's a lot of DevOps platforms to choose from. So I think especially in this domain, you're going to have a variety of tool chains, which with a different set of groups all deciding to use maybe their flavor of automation. And the big challenge is how do I tie this together and provide some standard self-serve portal northbound maybe into my IT systems that's the aggregate of the APIs from these systems with some automation logic, tying together my resource systems and those other things we talked about to provide a seamless single automation platform driving those cloud platforms. And the second we'll talk about, so the difference between these two is you saw in the cloud ecosystem, it's really kind of a layered approach. You have kind of the base cloud APIs, and then you're going to have a variety of tools stacked on top of it. And we believe the challenge for the automation platform is to really consume those APIs and use the right API for the right job and really provide kind of an all of the above approach. When it comes to SD-WAN 2.0, most of the time we're really talking about services that traverse multiple domains just to represent a single service. So just turning up your branch, while that's an important piece, obviously, to SD-WAN, doesn't anymore represent the sum total of what your end business owner is looking to achieve. So when we think about this, SD-WAN 2.0 is more complex than our traditional MPLS links, and we need to think about it from the beginning that complexity needs to be offset with some level of automation, or we're just going to pass that complexity on to our end users. So in this ecosystem, it's less about the stacked layers, and it's more about aggregating multiple domains together. So we talked about the cloud concept, so we can take kind of that previous use case and adopt that there. But the controllers and the techniques between our branch platforms and our data center platforms could be different. We could have a different data center controller. We might have different data center infrastructure. But the level of automation that exists within our data center and the level of automation that might be existing from our adoption of an SD-WAN platform, while different, still provide a robust set. And we could even, if we wanted to, extend this to some of the network applications that might be deployed at that branch, whether they be firewall or load balancers. So it's really about breaking down the end-to-end service into its constituent domains, and then thinking about the strategy within those domains, and then thinking about how we can aggregate that together so that we can continue to adopt these modern networks with all the business benefits they provide, but complement that with automation so we can not pass on that complexity. Because ultimately, if we pass it on, it's not going to be consumed to the level we all want it to be. So if we think about a typical SD-WAN branch turnup, and this is really talking more about what does it mean to be end-to-end, because the title of the discussion was end-to-end and multi-domain combined together. So if we think about it, there's really 5 major buckets when we think about doing a new branch turnup. We do some planning and scheduling. We do some design and preparation. We do the actual implementation, and then we verify it and we close it. And obviously we could have a bigger loop here where we're listening for events to make changes within that branch. But the main thing we wanted to focus on is that when people talk about adopting a modern network concept, or they talk about deploying SD-WAN, a predominant of that focus and energy is really around the implementation and activation. And when we think about the overall work effort to deploy a new SD-WAN branch, the implementation portion is actually a minority of the entire process. So when we think about the details that go into turning up a branch, and that's represented on the top, and I won't go into each of these. You can see them there. But if we broke it into those 4 categories, a whole lot of effort goes into that implementation and activation. And where we see some of the biggest benefit to drive automation and the quality of that actual implementation is to automate it from the beginning all the way to closure. So that means providing self-service interfaces. That means no swivel chairing between systems. That means integrating with whatever your change system is. That means integrating with your resource management, making sure that the offline data is as accurate with the network data. And all of this is ultimately going to help us be more effective if and when there's assurance challenges. And when we focus on kind of the end-to-end, we're moving away from just that network change and really looking at the end-to-end process, which ultimately is going to be represented by the network change, and will ultimately allow us to automate actually more activities and see a greater benefit to automation than just focusing on pushing configs to the network. It also, when we talk about low code, we look at the resources and the groups involved. When we sit down and start to map out these processes, it's obvious that we need a network engineer that understands SD-WAN to help with the deployment. But when we start to think about the number of people involved, sometimes there's a note to the NOC or the SOC that we're going to do something. There's a lot of integration with IT systems. Sometimes security people have to approve the types of resources or groups or access that a branch may have. So the number of people kind of explodes, and really providing that end-to-end automation both drives out outages within the turnup. It allows us to have better quality data offline, but it also provides more of a self-serve and automated ecosystem where each of those people can participate in the most effective way possible, which, one of the main drivers for automation is really about network velocity. So it's really about how fast can we turn these branches up We still want the people involved that need to be involved, but we need to present the information to them in the way they need to see it so they can move quickly. And obviously we can automate things more effectively if the quality of the data is offline, so we don't have to do as much fallout. So all of those things kind of play together, but we do think it's important to really view the end-to-end concept and stay away from just the independent pieces. And we talked about the data structures a little bit before. So as this applies to Itential, I've talked a lot around the APIs, around our open ecosystem, around our adapter builder that allows us to auto-generate adapters. But we think that's been the challenge that's been solved. So no one should be concerned with integrating a modern IT system with their modern networking system. That's, passing APIs back and forth is reasonable at this point. The next frontier for integration is really at the data level. And what I mean by that is the payload that's coming back through that REST interface, that JSON payload that's coming back, maybe that Yang model that's coming back from your network orchestrator, or the Tosca model from a cloud system. We're going to continue to see these payloads within these APIs be modeled more. Because what that allows us to do is it allows us to not hard code things on top of these systems. These models allow us to be flexible in our automation, so that if we have high quality data, then you can make a change within that SD-WAN platform, decide you're going to have a new group-based policy, decide you're going to have a new application, and we can just understand that and not actually have to reprogram any of the systems northbound. Right now, with most platforms, you make a change in the network and it has a ripple effect to the IT systems. And what this means is we all have to slow down and not make changes in the network. And ultimately, if we think back to those guiding principles, if we're going to work effectively, network velocity is key to a majority of those outcomes. And a key piece of that is, how do we understand these data structures dynamically? How do I understand DevOps YAML files? How do I understand network Yang? How do I understand Cloud Tosca? And we'll continue to get these models, but there's a very small subset compared to the APIs. And the more we can focus on a data level integration instead of just an API level integration, it's going to allow us to provide automation without as much prescriptive development that we have today. So this is the last topic for it, and we're really going to talk about infrastructure as code. I know we have 2 blank boxes right now, but just to kind of explain how we think about this, when we have a piece of hardware, and this piece of hardware can be in the data center, it could be an SD-WAN, it could even be virtualized. Then we have an operating system that gets deployed on this hardware, this piece of networking hardware. And today we think about network config as this aggregate, kind of atomic piece of config. It's this whole thing on the left. And to a non-network engineer, there would be nothing that would tell me that some piece of this config is much different than the other. We look at it as all equal, whether it's the host name or whether it's an interface definition or whether it's a routing protocol configuration. We just look at all of this as config. But when we start thinking about infrastructure as code, we think it's important to start breaking down this config into pieces. So some of that config might be day 0 and day 1. And we've kind of shown on the left-hand side which might map to that. And then we might have certain portions of that config that is really service-oriented or policy-oriented. So as we start thinking about how to think of infrastructure as code and apply it to network, we're less interested in thinking about the monolithic, this entire code config goes on this box, and more about what are the constituent parts of that config, and how do I make it more reusable. So just to look at this one other way, we would think about breaking down those 5 boxes into, a very specific example, a Git repo. So I might have a repo for making me a day 0 Arista switch. And then I might have some day 1 that says that I'm a day 1 Arista top of rack. And then maybe I have a specific Irish data center. So then I have a snippet of config that makes me an Irish data center top of rack Arista switch. And then I might have specific services on me that don't exist anywhere else. So I have a certain set of config that is exclusive to me. And then I might have some ACL policies that are specific to top of rack switches. And the benefit here is, today, those ACL policies or the day 1 top of rack config, that's on every single network device. So in the application development world, we would not store the same function call in every repo everywhere. But that's kind of how we do the network today. So if I have to change it, I have to go change it in all of those repos, which represent kind of all those devices. So in the future, we would have it in one place, like we would think about it as code. And then on the fly, basically, I would say I need to build a new top of rack number 15 Arista switch for Ireland, and I would have a build process that would take those 5 Git repos. I would have a manifest. I would lint it. I would do some static code analysis. I would test it, and then I would actually build that whole config. And I would still use the same tools I use today down there on the config deployment line. I would still use an orchestrator or Ansible or your DevOps tool of choice to actually push it to the device. So in this instance, the device doesn't see anything different. The device is still getting a config push using maybe min-diff concepts with rollback to the device. But what I'm actually doing is now I can rebuild that device anywhere in the world, anytime, because I have the config in my Git repo, and I can build it on the fly, and I can do some continuous improvement because I can continue to increase my static code analysis. I can continue to increase my parsing and my linting or my unit and integration tests. And ultimately, the benefit of this is we're going to do all of our testing before I actually put it to the device. If we think about how we manage networks predominantly today, we think we need to make a change. We make a change to the device, but then we put a lot of testing around it. We do pre-checks, then we push it, then we do post-checks, then we compare the two. We see, did we break anything? Did I break the neighbors? So basically, we're shifting everything left so that instead of making a change to the network and seeing if I broke it, now we're going to move that test logic we're going to move that to prior to the change so that I can continue to get better over time. And then ultimately, we can have different tooling that allows us to integrate with each of those repos that we can talk another time about how do we manage snippets of code, or how do we manage API calls rather than manage those monolithic configs that represent entire devices at a time. And ultimately, that's where we're going to end up with some infrastructure as code concepts. So with that, Stephen, maybe we'll open it up and see if there's any questions.
Yeah, Chris.
Or if you have any questions. Yeah.
Yeah, thank you. So again, if you are interested in asking Chris a question, please go to your Zoom dashboard. You'll see the Q&A tab there, and you can enter your question. I'm going to kick this off, Chris, with a question actually came into us via email just before the webinar started. The question is, does the Itential Automation platform support integration with SD-WAN solutions and next generation firewall products? And if yes, can you elaborate a little more?
Yeah, so the great thing about SD-WAN is that it is modern. So those vendors have done a great job of publishing their APIs. So we have a developer site. It's right down there, developer.itential.io. And what's on there is a list of the adapters that we have. There's also, we've open sourced a large number of these adapters. So they're actually on our GitLab open source repo, which is linked from that developer.itential.io. So we've been building those. We've been open sourcing those adapters. And then for any that we don't have, there's an actual adapter builder on the developer site, so that you can go to that adapter builder. You can upload the Swagger document or the Open API spec or a Postman collection, and you can generate an adapter from that. So yeah, we've done a lot of work in that realm, and we actually at the previous Onode we did a pretty big POC with, I think, VeloCloud, Viptela, and Riverbed as the SD-WAN controllers for a hybrid cloud POC.
Yeah, so maybe you could just touch on that a little bit. What's the typical approach to address, say, the SD-WAN use case? If a customer is going to adopt Itential to help automate their SD-WAN operations, take us through just maybe some simple steps and approaches.
Sure. So, it's really a lot of times use case driven, as this is a new is a new technology for most customers adopting it. They really focus on kind of new branch turnup a lot of times as the first use case. So when we talk with customers, it's really independent of their choice of SD-WAN technology. that's less concerning to us. I know there's a whole lot that goes into deciding which SD-WAN product is best for a specific customer. But we really look at the services and the use cases that they want to deploy. So a lot of times it's turn up. So it's that whole concept of day zero and day one. So it's what types of infrastructure are they going to use, what type of controller are they going to use, and then which services they're going to offer. And we really kind of, back to that SD-WAN breakdown, look at what are the types of interfaces we need, what are the types of models, and what are the processes that we're going to automate to support that turn up. And it's really driven, people have a lot of times very aggressive rollout schedules as they adopt those technologies. And then we map that to their internal IT systems and start moving forward with automation. But I think kind of the process we walked through today, applied specific to a customer's deployment, is really the way we do it.
Great. Another question here is, you've got SD-WAN controllers that are starting to integrate hooks for things like cloud security, Zscaler, or integrate hooks directly into the cloud service provider platforms themselves. So what role does Itential play as we, see greater integration from a SD-WAN platform perspective?
Yeah, so with SD-WAN starting off as kind of the split between the MPLS and internet links and the story everybody knows, we think it's fastly going. It's really moving quickly towards those SD-WAN providers aren't going to stand still, right? They see their customers integrating. I think you brought up Zscaler with their SD-WAN, so they're going to provide a direct integration between that SD-WAN service and Zscaler, which we think is awesome. So from an Itential standpoint, we are always embracing those types of moves because we think that we want to provision through the highest level abstracted interface. I think I said earlier that's available. So in some instances, there's very little automation in place, all the way down to CLI and script. So we have a product called Automation Gateway that goes and allows you to execute those scripts locally. And then you have some very robust things, where maybe an SD-WAN controller is integrated with Zscaler in a hybrid cloud environment. So the use cases where we're provisioning a service, maybe that's a simpler execution on the Itential side because there's an integration horizontally between those two platforms for the purpose of that service orchestration. But what that allows us to do is just focus on all of the other use cases to provide a fully automated environment. So whether it's data center or SD-WAN, the more integrations between these platforms is awesome. The part that I think some people get hung up on, and maybe this is a little bit of a tangent here, is that we think about an architecture as a series of boxes stacked on top of each other. So, historically we'd have EMSs, and you had your NMS on top, and then you had your IT systems, and we thought about flow through, and it went from system to system to system. And the way we're seeing, the network world play out is a lot like we see the application development or the general IT ecosystem is, depending upon the use cases, those boxes move around, right? So who talks to who for a new branch turnup might be one direction, and then who's talking to who for some service provisioning activities that actually might flip around. So, we're going to forever see these different systems integrating with each other. We think the most important thing for people to take into consideration is really about creating that API ecosystem within their networking world, so that they can provide their teams the flexibilities to automate any given use case or process in the way that makes sense, and not have artificial constraints of how systems talk through one another. So we're really going to see kind of more of an API ecosystem, so that customers have the flexibility to integrate it in the way they see fit. Maybe that was a little tangent for the question, but.
Well, yeah, so that leads me to, maybe you could talk a little bit more about how Itential, creates that better linkage and integration between operational silos across multiple domains. I mean, you touched on this, I think, on the slide where you talked about the unified operation models and the data level integration. So, obviously there's all the automation that's going on within a domain, within a silo, but then there's sort of how you tie that together, for something like SD-WAN or maybe multi-cloud or both. Maybe you talk a little bit more about what's kind of going on there under the hood.
Sure. So, we stayed away from architecture and kind of how Itential works today to focus on end-to-end and multi-cloud and some of the market dynamics. But if I was going through an architecture kind of discussion and kind of how the intellectual property behind the scenes works, the technology works. We're really big, leveraging those integrations from an API level and also integrating at the data structure level. It's really about providing appropriate abstractions. So we want the user, the network engineer, the developer to have the appropriate amount of detail that they want. Now, the reality is that, as these networks grow, the thought of having a single controller interface or a single self-serve portal for all of your networking needs across, network applications, cloud, branch, et cetera, we're still going to have some level of silo within, just the controller and orchestration layer. So what Itential from a multi-domain perspective does is it takes those data structures, YAML, Yang, Tosca, and internally we translate those into a generic model that we can provide northbound. So what that means to the average user is that I can have a self-serve interface hooked up to Itential, and I can just say in a very intent-based, abstracted way, I want a new firewall rule at this branch, or I want a new DNS deployment in this data center, or I want a new VPC from, cloud endpoint A to site branch B. And what we'll do is we understand the technologies that customer is deployed for that branch, because you might have multiple branch technologies, you might have multiple clouds, you might have multiple data centers, you might have multiple firewalls, you might have different vendors, different structures, different controllers. We provide that abstracted interface and what we believe is a real intent-based interface, so that you can just ask something to happen and you don't have to concern yourself with the ultimate provisioning of that is across netconf or across a specific REST-based interface. So within that low-code environment that the end user is working in, if you want to, you can tell, but you don't need to understand necessarily the implementation specific details behind that. So we really want to provide that intent abstracted interface in that multi-domain concept. So you generally know what you want to do, but you don't necessarily have to be concerned with how it's going to happen.
Right.
And that level of abstraction provides the great benefit, especially when people start looking at their DevOps platforms. They won't have one or two, they'll have 10 or 20. And in the future, you don't want to have to say, I want this to happen on, this engine in this data center. You just want to ask that it be done, and we'll route it to the correct place and make sure that the payload and the data structures are right.
Great. Well, if you could advance to the next slide, we're coming up on the top of the hour here. So before we wrap up, I'd like to invite everyone to, please join us in New York for ONUG Fall 2019. We've got a great and stimulating conference agenda we've put together. The attendees will get to meet with Itential and many of the other event participants. We've got IT executives, we've got solutions integrators, vendors, cloud service providers, communication service providers, and everyone coming together to, look at how we're going to overcome these challenges of deploying IT applications in these new hybrid multi-cloud environments. So with that, I'd like to kind of thank Chris for the insightful material he shared with us today. And I'd like to thank everyone for participating, and have a great day. Thank you.
Thanks for joining us.